places where the flow of water in a stream has been measured and recorded at regular intervals. The period over which records are available varies greatly, depending on the importance of that stream at that place. No records are available for the Victoria River or for the Cobungra River above its junction with the Victoria River. The closest place with records is station 414 on the Cobungra River, about a kilometre downstream from its junction with the Victoria River. However, these records are only for the period 1925 to 1935, and we're interested in 1908 to 1916. The Cobungra River flows into the Mitta, for which flows have been measured at several places. Relevant to us is station 406, Hinnamungi, and much further down, station 205 at Talangata, where records span a long time. Here are the total annual flows for three places for the years 1926 to 1934. The bottom one is for the Cobungra River at station 414, and the others are for the Mitta at Hinnamungi 406 and Talangata 205. The similar shapes of these curves support the idea that the flow in the Victoria River, for which data is not available, can be roughly inferred from the flows recorded in the Mitta at Talangata or Hinnamungi. Here are the annual flows in acre-feet in the Mitta at Talangata over a 50-year period. Of interest to us is the section between the broken vertical lines 1908 to 1916, when the Victoria Falls power station was operating. The only exceptionally dry year was 1914. 1908 was slightly low and 1909 was high, but the other six were close to average. The Cobungra River was frequently suggested as an alternative to the Victoria River. Minimum monthly flows at station 414 were recorded over a 10-year period. They are plotted here. The vertical scale is the flow in cubic feet per second. Now, to produce 400 kilowatts output from the turbine at Victoria Falls, the turbine needs 20 cubic feet per second. Looking at the summer period, in 7 of these 10 years, the lines go below the 20 line. So in 7 of these 10 years, the full 400 kilowatt output would not be available for 3 or 4 months in summer. To supply even the 188 kilowatts maximum, which was used in 1909, about 9 cubic feet per second would be needed. For 3 of these 10 years, even that much was unavailable for the 3 or 4 summer months. If the Cobungra River is to be used instead of the Victoria, we need to know where it would have to be tapped to get the same 120-metre head. On this contour map, the red line shows that the water race would have to be about 30 kilometres long, compared with 6 kilometres for tapping the Victoria River. So, for this reason alone, tapping the Kavunga River is not an easy solution. When we started this research in 1979, we visited the site of the offtake to see what remained of the earth dam across the Victoria River. It was completely overgrown, with trees growing on the ends of the earth wall. It was obvious where the water race had started, with various sections of rock wall. There was a long metal rod projecting out of the riverbed. This turned out to be the threaded screw which had raised or lowered the sliding steel outlet gate, which was built 63 years before. With the vegetation now removed, the remains of the dam are very clearly visible. At the end of the road was the pondage. It still had the concrete intake structure and the first tapered steel section which led to the pipeline. The pipe had been dug up and removed after the auction. A rough path down the hill leads to the foundations of the power station, where the positions of the main and auxiliary sets are clearly visible. At one side stands the tall concrete structure which housed the surge diverters and from which the 12 kV transmission lines left the power station. This picture from across the river is taken from about the same position as the earlier photo as judged by this concrete structure. On the back of the concrete, we were intrigued by the name and the dates. These spanned the last 8 months of operation of the mine and the 9 months after the final auction. While reading Omeo newspapers in the La Trobe Library, I had seen advertisements for a Crackie's store, so this was a local person. At the Omeo Shire offices, we were shown a collection of old photographs, including some of John Avery's, and we asked about L.T. Crackie. We were told that was Les Crackie and he's still alive. Les was living in Bairnsdale with his daughter. He was delighted to meet anyone interested in the hydro scheme. The story was that most of the young men in Omeo had gone off to the war, but Les was not accepted because his father had been born in Germany. Instead, he was given the job of running the power station during its last months of operation and then dismantling all the plant after the auction. He produced the reference he had been given when he finished the job. He was asked to accompany the plant to Tasmania and erect it for its new owners, the Magnet Silver Mining Company, but he declined. He volunteered again for the army and this time was accepted. Later, he returned to Omeo and set up a local electricity supply business, and this served Omeo until the SEC arrived many years later. Les told us more about some of the Avery photos we had, and we recorded his memories of working at the power station. I told him that Edgar Wright's article said to augment their food supply, the shift engineers looked for fragments of trout in the tail race coming out of the power station. After getting through the screens on the pondage, they'd been smashed up by the Pelton wheel. Les said that still happened occasionally during his time, when he lived beside the power station. Lot 661 in the 1917 auction catalogue was 2 huts at station with iron roofs, 2 tables, 3 stretchers. This Avery photo shows 2 stretchers and 1 table in a compact room, which probably housed the shift engineers running the power station. There were probably plenty of strong wooden boxes available to keep things in. Les said he lived there, slept in one and cooked in the other. There was a panel with 5 Avery photos. The bottom 2 were of this same hut, interior and exterior. Judging by the items on the bench, this well-built hut is being used. The other 3 photos are of waterfalls, probably on the Victoria River at times of good flow. Behind the power station, we found an old telephone insulator. Ray Sumner organised a group to walk along the 24-kilometre route of the transmission line. This turned out to be still marked on the current parish plans. They didn't find any chopped off power poles, but they did find 1 broken insulator. The rest were probably recovered and sold, as the high voltage line was not needed at Magnet because the power station was right next to the plant. This was the end of the line when the plant was working. The line came into the right-hand end of the substation in the bottom right corner. I've attempted to take a view from the same place. You can see the concrete cubicles underneath the tree where the high voltage wires came in, and now very heavily overgrown. Looking from the same viewpoint, the battery was just like right of centre. Nowadays, looking at the same view, you can just make out where the battery foundations would have been. Going much closer, these were not taken away. All the rest of the machinery has long since gone. From further up, looking past the plant, at the bottom of the hill are all the remaining deposits of sand and tailings. A lot of these have been removed for retreatment under more modern methods to recover more of the gold. This was the substation at the branch of the transmission line which led to the mine. All that remained are the concrete cubicles that held the surge diverters and the entrance to the mine itself. Modern miners have attempted to get further gold, But if one can get access along the horizontal adit tunnel to the machinery chamber, this is where the powerful double drum winch serviced the shaft. The grease marks on the wall are still there. The head frame over the shaft still remains, and also a few relics of the winding signals used by the winch operators. In 1980, Ray Sumner and I produced a paper embodying all we had found about the scheme up to that stage. All this research on the Cassilis gold mine and its hydroelectric power station led to two historic areas being declared by the Land Conservation Council of Victoria. The first, of about 100 hectares, covers from the Great Alpine Road to the power station site. The other, larger one, covers the Cassilis and King Cassilis mines, the gravity tramway, and the treatment works. In recognition of the achievement of what I believe was Victoria's first significant hydroelectric scheme, the Engineering Heritage Group of Engineers Australia awarded a historic engineering marker. November 2008, a major ceremony was organised jointly by Parks Victoria, Engineers Australia, the Omeo Historical Society, and the Friends of Cassilis. This was timed to mark the centenary of the first operation of the power station in 1908. In the centre of this group is Mark Avery, John Avery's grandson. After his father's death in 1996, he handed over to me 270 half-plated glass negatives taken by John Avery nearly 100 years earlier. Some of these had suffered water damage, but most of the 70 which relate to the Victoria Falls scheme were in good condition. The plaque was unveiled by the local Member of Parliament, Craig Ingram. A major supporter was David Foster, the Chief Ranger of Parks Victoria at Omeo. He organised extensive upgrading of the information displays, both at the Central Display Centre and displays distributed around interesting parts of the scheme. Finance was received from the Community Grants Program of Parks Victoria, and this provided durable interpretive signs. They were appreciated by the people who attended the unveiling, and they'll be of great use to people who come and stay in the delightful camping area provided by Parks Victoria. In 1981, I visited the site of Magnet in northwest Tasmania to see what remained of the hydroelectric plant which had been taken there after the Cassilis Company's final auction sale in 1917. Magnet had been a small community